Okay, ladies and gentlemen, let's start talking about the triangle proportionality theorem. Now, let's talk about the words that are in it first. First of all, it says triangle proportionality. So triangles with proportion. So obviously, somewhere in this mess, we're going to get something over something equals something over something. We're going to get some sort of proportion. Let's draw a triangle here. And let's start with this triangle here. Let's assume it's not isosceles. Let's make this side 9 and let's make this side 6. That means in this triangle we have a ratio of sides of 9 to 6. Now, let's take a line and make it parallel to the base. So if I cut this triangle parallel to the base, just like that, what I've done is I've now made a shorter side, and that shorter side, let's call it 6. Let's do it in green. How about that? Let's call it 6. And so if that's 6, this has to be, well, 3. And if this is 4, then this has to be 2. Now, what we can say about the larger triangle and what we can say about this triangle here is what? Well, obviously, they're going to be similar because if these two lines are parallel, this angle is congruent to this angle. This angle is congruent to itself. So now I have one pair, two pairs in these two triangles. So those two triangles are indeed similar. Well, if those triangles are similar, that must mean their sides are proportional. Well, 9 to 6, let's see, is that the same as 6 to 4? In fact, 36 equals 36. Yes, indeed it is. They are proportional. But here's something else, and this is where the triangle proportionality theorem comes in. It says not only do you create two similar triangles with sides that are proportional, you create two other pieces that are proportional. The chunks you cut off also remain proportional. So just like this is 9 to 6, and just like this is 6 to 4, this is going to be 3 to 2. Well, let's see here. Does 3 to 2 still match? Well, let's take 6 over 4, 3 over 2, and you come up with 12 equals 12. 9 over 6 equals 3 over 2. There you go. 18 equals 18. Yes, it is. So when you cut this apart, you actually create proportional chunks. In fact, let's drag these sides on down and drag this side on down. If I were to cut it again, the kicker is that these lines are all parallel. 1, 2, 3 are all parallel. They must be what to create proportional sides? Parallel. And if we do, let's say for some reason that this is 4. My question is, what is x? Well, I could use any of these. I could say 9 is to 6 as 4 is to x. And I come up with, well, let's see here, that's 24 equals 9x. Well, I don't know what that is off the top of my head, but I can grab a handy dandy calculator, and I bet you we'll find out. And so I take, clear, 24 divided by 9, answer is 2.666666. Okay, we say, well, I don't like that one. Let's use 3 is to 2 as 4 is to x. Okay, fine, let's cross multiply that. You get 8 equals 3x. All right, so let's take 8 divided by 3. Answer is 2.666666. It doesn't matter. It's 2 2/3. Okay, 2 2/3. Reason being, doesn't matter as long as these lines are parallel. It's going to cut these two triangles proportionally. In fact, that actually brings us to another theorem. And the other theorem that we have is it doesn't even have to be a triangle. It could simply be any three parallel lines cut by two transversals. Any three parallel lines. 1, 2, 3. Parallel, parallel, parallel. Transversal, transversal. Now, in this case, if I were to draw them on up, they would indeed make a triangle. But this here, without the triangle, is actually called the proportional parts of parallel lines. Now, let's say that 3 times fast. Proportional parts of parallel lines. So proportional parts of parallel lines, proportional parts of parallel lines, proportional parts of parallel lines. All right, so proportional parts of parallel lines. There you go. what it says is this side, if this is 3 and this is, I don't know, 1.5. If this is 2, this has to be proportional to it. So we would say 3 is to 1.5 as 2 is to x. And we would cross multiply and we get 3x equals, and it's going to be 3x equals 1. That doesn't shock anybody. And you say, well, fine. So it works like this. Does it work like this? Well, let's find out. 3 is to 2 as 1.5 is to 1. Answer is, yeah, it does. Now, let's do something a bit more difficult. Let's do something like this. I have 1, 2, 3 lines, cut, cut, parallel, 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 and I have x plus 1, and x, and 4, and 3x. Let's see here. Let's see if we can make this guy work. What we should know is that this is to this as this is to this, or this is to this as this is to this. It's just like similar triangles. As long as you're comparing corresponding parts, it doesn't really matter. So let's set it up. X plus 1 over 4 equals x over 3x. Now, what do you have to do to solve a proportion? You would cross multiply. And your answer would be 4x equals 3x squared plus 3x. Now, how did I get that? Well, because this is in parentheses, so 3x times x, 3x times 1. Works out very nicely. Now, in this case, I'm going to need to solve. What is the first step to solving this for x? The answer, of course, is trying to get everything to one side by subtracting 4x. And now we start to do what to get x by itself? We're going to factor. So 0 equals x minus 1 times x. How do you actually finish finding a number for each piece? Set each piece equal to 0. There you go. And so we would say 3x minus 1, x equals 0, 3x minus 1 equals 0, x equals 1/3, x equals 0. Those are your two options. Now, x equals 0 doesn't really make a bunch of sense because I'd have 0 over 0, right? Okay, but if I have 1/3, I have 4 is to 1 and 1/3, as 1/3 is to 3 times 1/3, which is 1. Does 1/3 go to 1 the same way 1 and 3/4, 1 and 1/3 goes to 4? The answer is yes, they are indeed proportional. So that is using properties, proportional properties of parallel lines, proportional properties of parallel lines. Now, we have one other thing we need to talk about while we're in this section, and that is midsegments. Midsegments. Now, a midsegment is exactly what you think it is. If I have a triangle, A, B, C, and I draw a segment that connects the midpoint. So here we go. That's the midpoint of that side, or as best as I can guess for you. And here, this is halfway, so that cuts it in half. And so then that means I can draw this segment in. What's the first thing that must be true about these two segments right here? We'll call them DE and AC. What must be true about them? The answer is parallel. Because we just said that in triangles, if lines are parallel, these are proportional. Well, take a look. Is this the same exact as this? Yes, so this is to this as congruent is to congruent. So these two have to be parallel. So midsegments have to be parallel. Additionally, DE is going to equal 1/2 of AC. Now, I think we've actually talked about this in class a little bit before, but if you think about it, let's assume this has a length of 8 inches right down here. It would make sense that the mid segment, being in the middle, since I have 8 here and I have no side up here, so that's 0, midway between that would be 4. So a mid segment is half the length of the base segment. Mid segment is half the length of the base segment. Now, while we're at this, we can do another little cool thing. Let's take this triangle here. I want to go halfway. I want to go, it looks about like halfway. And here I have halfway. All right. What I end up with is I end up with this midsegment, which we now know is half of the base. Well, if this one is a 2 and a 2, but there's two of them, that means this is a 2 all by itself. If I draw this midsegment in, this is 1, 2, 3, 1, 2, 3, but it's half as big, so it's just 1, 2, 3. So instead of two of them, there's one of them. And finally over here, I have a single because half of this is this. What is true about this triangle, this triangle, this triangle, and this triangle? All right, that's what you need to be able to tell me. Okay, take a look at some of the either quiz questions or Zaption and make sure it's all done.